Okay, here we go, rocking into homework set 36 with this problem on page 499, problem 104. You have assigned to you 103, very similar, two very similar problems, 103, 104. So let me see if I can kind of motivate how one would do this. We're dealing with, the name of this is dealing with double and half angle formulas. And right, these two sets of formulas relate theta to 2 theta or theta to 1/2 theta, theta over 2. And that arises, think about a geometric problem where you've got an angle and you bisect it. So you take the large angle theta, bisect it and turn it to two angles, theta over 2 and theta over 2. So there's a geometric relationship then going on between theta and theta over 2. And if you let trigonometry get involved in the following analytic geometry, you might need a way to convert from trigonometric functions of theta to trigonometric functions of 2 theta or 1/2 theta. So they come up a lot. They can be derived in a heartbeat. I'm going to do it here in this case from the sum and difference formulas. For me, the only issue is they take both of them, both the double angle formulas and the half angle formulas. They take different forms. That is, there's a couple of different forms for cosine of 2 theta in terms of sine and cosine of just theta. And likewise, there's a couple of different forms of sine of 2 theta in terms of sine and cosine of theta. But that aside, hey, we're stuck with trying to do this problem right now. And this problem says if x is equal to 2 times tangent theta, express cosine of 2 theta as a function of x. So if we can just get our heads around what this question is asking, it'll certainly help going forward. It'll kind of suggest what we ought to do. So here's a relationship between x and a function of theta. This wants you to make find a relationship between x and this function of 2 theta. Different functions, tangent in this case and cosine in this case, but notably different arguments, theta in this case and cosine of 2 theta in this case. So what do we know? We know that x over 2 is equal to tangent theta. What I need to do now is relate tangent 2 theta to tangent theta to cosine 2 theta. And how the heck do I do that? We know, and so let's relate tangent theta to cosine 2 theta. And how do we do that? Through the double angle formula. For cosine 2 theta. Because after all, that formula is in terms of sines and cosines, and maybe we can figure out how to work a tangent theta in there. And maybe that's the first thing we have to do. In fact, that's kind of the key. Let me see if I can get myself to say that again. So let me read what I've just written. We know that x over 2 is equal to tangent theta. So let's relate tangent theta to cosine 2 theta through the double angle formula. So we know through the double angle formulas that we can turn cosine 2 theta into sines and cosines of just theta. So how do we relate the tangent to the sines and cosines? That's the trick. And here's the answer. Let's use tangent squared theta plus 1 is equal to secant squared theta, which, oh, by the way, is 1 over the cosine squared of theta. Okay? So what did we just do? First of all, we just used a very basic Pythagorean identity. Tangent squared plus 1 is secant squared. We use this reciprocal identity. The secant squared is equal to 1 over the cosine squared. And now we did just what we said we wanted to do. We related tangent theta to cosine theta, and we can make use of that to relate cosine theta and sine theta to cosine 2 theta. So let me stop talking and let me start doing it. since this is a basic identity, and we know that tangent theta is equal to x over 2, this says x squared all over 2 squared plus 1, put x squared, replace tangent here with x over 2, so x over 2 squared plus 1 is equal to 1 over the cosine squared theta, and that says that the cosine squared theta is is equal to, I'm just going to go like this and blow your mind a little bit, right? If I combine these two, multiply the one by 4 on the top, 4 on the bottom, then this is x squared plus 4 over 4. And if I turn this side upside down and this side upside down, I get this. Okay, so now we've gone way down the line here because I have a relationship between x and cosine squared theta. Oh, by the way, I want to now get a relationship between cosine squared and cosine 2 theta. So let's just go back to the sum. If I can't remember cosine 2 theta, and I guess I can, but I'm just going to do it like this. Cosine theta plus theta, that's, oh, by the way, that's cosine 2 theta. It's cosine theta times cosine theta, cosine squared theta, minus sine squared theta times sine squared theta times sine squared theta. So there's one of the manifestations of the cosine double angle formula, if you will. And I'm way down the road here because I now can write in cosine squared theta as a function of x. And oh, by the way, I'm getting pretty used to going back to yet another trigonometric identity. Well, let's see how many miracles we had to have in this case. You know, we made use of this identity right here. We made use of, which was this identity. We made use of this reciprocal identity. I just pulled out this third identity, which is the double angle formula. And here I'm going to give you the fourth one right here. Remember that sine squared theta is equal to 1 minus cosine squared theta. And that's because sine squared plus cosine squared is equal to 1. A fourth identity, or a fourth miracle, if you will. So let me write this as cosine 2 theta is equal to cosine squared theta minus sine squared, which is a minus 1 plus a cosine squared theta. Okay, so if I just kind of clean this up a little bit, cosine 2 theta is equal to 2 cosine squared theta minus 1, cosine, minus 1. And what is cosine squared? Well, it's right there. So it's 2 times 4 all over x squared plus y squared minus 1. 2 times 4 is 8. Okay, and what the heck? How do I, let's make this into one fraction. So that's 8 minus x squared plus 4 all over x squared plus 4. And I'm wondering if that's the right answer. I sure hope so. Let's see. I've got cosine 2 theta is equal to 4 minus x squared all over 4 plus x squared. It feels right. It feels right. We've done what we've asked to do. If x is equal to 2 tangent theta, express cosine 2 theta as a function of x. And there it is.